Question 1. In this question we are asked to find the derivative and plug in -1 into its derivative from the expression g of x, which is e to the power of x squared plus 1. Now, whenever you want to find the derivative of an expression with e in it, all we simply do is we take the derivative of what's on top of the e, in this case it's x squared plus 1, and we put it in front of the expression. So in this case, e to the x squared plus 1, the derivative of x squared plus 1 is simply 2x, and I'm going to simply put that 2x in front of the initial expression. Now we have the derivative. I can simply plug in its restriction, which in this case is -1. Plugging in the -1 into all the x's, I will eventually obtain -2e squared, and that is our final answer. Question 2. Part A. So in part A we are asked to find the coordinates of the center of the circle, and we are given that point A is 1, 4, 0, and point B is -3 to -4. And we can simply recognize here that to find the coordinates of the center of the circle, we can simply use the midpoint formula. And this is given in our data booklet right here. It's this formula right here. And we can recognize that for the first set of coordinates, 1 is x1, 4 is y1, and 0 is z1. And for the second set of coordinates, -3 is x2, 2 is y2, and -4 is z2. Simply plugging these into the equation, we will eventually end up with -1, 3, -2. And in part 2 of question A, we are asked to find the radius of the circle. And here we can simply recognize that the radius is from the center to either point A or point B. Now, what I'm going to do here is I'm going to use another formula in our formula booklet, and this one is known as the distance formula, which can be found right here. What I'm going to do is I'm going to use point A as well as the midpoint, what I just found before. I'm going to substitute all those values into the equation, and I will end up with √9, which is the same as 3. So therefore our radius of the circle is 3. Now in part B we're asked to find the exact volume of the cone, and to do this we can also look at our formula booklet. In fact, the formula of a right cone is given right here. That's 1/3 pi r squared h. Now if you look at it, we already have r, however we do not have h yet. H is the height from the center of the circle to V. We are however given the coordinates of V, which is -1, -1, 0. Once again, we can use a distance formula here, the same formula we used before, and we can use the points from the center of the circle as well as V. I'm going to plug these into this equation, same one that we used before, and I will end up with √20, and this can also be just rewritten as 2√5. Now we have all the values we need. I can simply plug it into our equation. 1/3 times pi times 3 squared from the radius times 2√5 from the height, and this multiplied together gives us 6 pi √5. As our final answer for the volume. Question 3. And in the first part of this question, we are asked to show that a squared plus a squared minus 1/2 all squared is equal to a squared plus 1/2 all squared. Now, in order to do this, I'm going to separate left-hand side and right-hand side. This allows me to eventually prove that both sides equal each other. So I'm going to take this as my left-hand side and this as my right-hand side, and I'll separate them. Here we go. This is my left-hand side. And I'm first of all going to expand this part. So I can just rewrite this as a squared plus a squared minus 1/2 times a squared minus 1/2. Now multiplying these together, a squared times a squared is a to the power of 4. A squared times -1 is -a squared. This is also -a squared, and this equals to 1. So now we are left with a squared plus a to the power of 4 minus a squared minus a squared plus 1 all over 4. Now what I want to do is I want to add this a squared, but in order to do that I also need to put in a common denominator. So I'm going to times the top by 4 as well as the bottom by 4. So now I have 4a squared over 4 plus the expression on the right. Now I have this, I can combine them with the common denominator. I can simply add this to that. Therefore I have a to the power of 4 plus -2a squared plus 4a squared is equal to 2a squared plus 1 over 4. My right hand side, I simply need to expand this expression. I can rewrite it as a squared plus 1/2 times a squared plus 1/2. A squared times a squared is a to the power of 4. A squared times 1 is a squared. 1 times a squared is a squared. And 1 times 1 is 1. Adding these all together, I eventually get a to the power of 4 plus 2a squared plus 1 all over 4. As you can see, my left-hand side equals to my right-hand side. Hence, I've shown that this expression is correct. Part B, I need to find an expression for the area of the triangle. And in order to do this, I'll quickly just take us back to part A. Part A told us that a squared plus a squared minus 1/2 all squared is equal to a squared plus 1 over 2 all squared. And if you quickly think about it, Pythagoras' theorem simply states that a squared plus b squared equals c squared. Now what I can do from this, I can remove the squares and write a triangle. Hence my a squared would be this part, my b squared would be this part, and my c squared would be this part. To find the area of a triangle, you simply need to do this formula, a half times AB, or otherwise known as a half times base times height. Substituting in these values, I can get a half times A from the bottom, times a squared minus 1 over 2 from the side, and combining these, I will either get a cubed minus a over 4, or this expression, a times a squared minus 1 over 4, and that would be our final answer. Question 4, and in this question we are given the derivative function, which is defined as 6x over x squared plus 1, and we are asked to find its integral, f of x. We're also given a set of coordinates which will allow us to find the value of c after integrating the actual thing. So I'll take you through the integrating process, and the integrating method we are going to be using here is use substitution. So essentially what I'm going to do is I'm going to write the integral of 6x over x squared plus 1 dx. That has to be part of it. What I'm going to do now is the substitution process. I put it in blue here to make it a bit easier to follow. I'm going to replace x squared plus 1 with u. I'm going to write that here. Next, I'm going to have to differentiate both sides. This is just part of the process of u substitution. The derivative of u is du. The derivative of x squared plus 1 is 2x dx. What I want to be able to do is I want to be able to replace this dx with another thing. So in order to do that, I can simply rearrange to put dx on its own. I'm going to divide both sides by 2x, which gives us that dx is equal to du over 2x. Next, I'm simply going to rewrite the expression as 6x over u, since x squared plus 1 is now u, and dx is now du over 2x. Now what you can see here is that 2x and 6x, they can simplify. If I divide both by 2x, then I am simply left with 3. So now I simply have the integral of 3 over u du. And if you've done a bit of integrating before, you know that when there's a fraction like this with a variable underneath, you can simply write it to be ln, or natural logarithm. In order to take the integral of this, I simply put 3 times natural logarithm, or ln, of u plus c. And now I've got this integral, I can simply plug the u value back into the new value found. So I now obtain 3 ln of x squared plus 1 plus c. Now, they actually gave me a set of coordinates, so I can actually find the value of c. What I can do here is this. I know that y is 5, so I can say 5 equals to 3 ln of 1 squared plus 1 plus c. I can simplify this to be 5 equals to 3 ln of 2 plus c. Now there's no clear thing what I can do here to simplify the value, so I can simply just rearrange to have c on its own. So c equals to 5 minus 3 ln of 2. Now I actually have everything I need. I can simply write down the f of x, and f of x is just 3 ln x squared plus 1 from this part, and then the c value is simply this, plus 5 minus 3 ln 2, and that is the final answer to this question. Question 5, and in this question we are given a polynomial equation, and we are also given 3 of its roots, and by considering the product of all these roots, we are asked to find the value of a. Now, we need to use a little bit of our knowledge here of conjugate pairs. Given that one of the roots is 3 plus I, we also know that another one of the roots is 3 minus I. Okay, so, it asks us to consider the product, so we can immediately know that we have to multiply these together. However, we do not yet know what we have to equal them to. Therefore, we can use the formula, the product formula, which is simply z over a. So in this case, it would be 80, the last thing in the polynomial, divided by the first one in the polynomial. Simply, it's 80 divided by 1, which gives us 80. So here we can now multiply all the roots together and set them equal to 80. Now, quickly expanding this, 3 times 3 is 9, minus 3i plus 3i minus I squared times a cubed is equal to 80. Here simply the minus 3i and the plus 3i cancel out. And once again, we need to use a little bit of knowledge here for the I squared. I squared is actually equal to negative 1. And negative 1 times negative 1 is simply 1. So 9 plus 1 is 10. 10 times a cubed is 10a cubed, equal to 80. We can simplify this to make it a cubed is equal to 8. And therefore, a is simply equal to 2. Now, in part B, we are asked to find the value of p. And here we need to use our knowledge of the sum of products of roots. Now, what we can simply do here is add all the 4 roots together. 3 plus I plus 3 minus I plus a squared. Given that a is 2, we can simply put 6 plus 2 plus 2 squared, and this ultimately makes 12. Now, to actually solve this question, we also need to use a little bit of skill here. Similar to the product one, there's also a sum rule. The sum rule is simply minus b divided by a. So you need to minus the p, the second thing, so minus p divided by the first one, 1. So minus p divided by 1 is simply minus p. So now we know that minus p is equal to 12. And just switching the signs, we then know that p is equal to minus 12. And that is the final answer. Question 6, and in this question we are given two events, A and B, such that the probability of A is 0.3 and the probability of B is 0.8. And in part A we are asked to determine the value of P of the probability of A intersection B, in the case where both A and B are independent. And here we can simply use a formula in our formula booklet, which is called the independent events formula. It simply states that the probability of A intersection B is equal to the product of A and B. Very easy, all we do is plug in the values that we know. We simply do 0.3 times 0.8, and that gives 0.24 as the answer. Now part B is a little bit more tricky. In this one we are asked to find the minimum possible value of probability of A intersection B. And first we need to think a little bit about the probability of the A union B. A union B is simply everything that's possibly there in the whole set. Now, basic rule is that everything in the probability sets has to add up to 1. 1 is the maximum possible value. So here we can just simply say that the probability of A union B, everything in the whole set, is either equal to 1 or less than 1. From this, we can then use another formula in our formula booklet. It is the combined events one, and it simply states that the probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersection B. Writing this formula down, and then rearranging to make probability of A intersection B, the product of the formula, as we are asked to determine that value. We now have this formula. And given that we have all the values we need to know, we have 0.3 as probability of A, or 0.8 as probability of B, and we have 1 as the probability of A union B. Solving this very quickly, it just gives us 0.1. Question 7. And in this question, we are given a curve with equation x squared plus y squared times y squared is equal to 4x squared, and we are asked to show that the curve has no local maximum or local minimum points. And with our knowledge of local maximum and local minimum points, to find those points, we need to find the first derivative and set it equal to 0. Now, as you can see, there's y's involved in this equation, so what we're going to need to be using is implicit differentiation. First of all, I will just simply expand what we have here. I can simply multiply y squared by both x squared and the other y squared, which would then give me x squared y squared plus y to the power of 4 is equal to 4x squared. Now I have this, I will take the derivative of both sides. I will write it like this: d dx of the left side is equal to d dx of the right side. Now actually differentiating this. The first part, the x squared y squared, is actually a little product rule, and I wrote it here on the right in blue to make it a little bit easier. What I'm going to do is I'm going to treat the x squared as f, and I'm going to treat the y squared as g. This way I can then apply my product rule formula. First of all, as I know that f is equal to x squared, I need to find its derivative, which is simply 2x. Same for g, y squared, and its derivative is 2y. What I'm going to do now is I'm going to multiply f prime by g, as here, 2xy squared, and I'm going to multiply f by g prime, x squared times 2y. However, this is very important. This is part of the whole product rule, implicit differentiation rule. The second one, the f times g prime 2y times x squared, actually also takes a dy dx. That's what I've written here. Then the derivative of y to the power of 4 is simply 4y cubed dy dx due to the implicit differentiation rule. And then the derivative of 4x squared is simply 8x. Now I'm going to try and solve for dy dx to be on its own. What I'm going to do here is I'm going to write dy dx. I'm going to write the ones that actually have dy dx on them. In this case, it's x squared 2y plus 4y cubed. And I'm going to bring this one over to the other side to make it 8x minus 2x squared y. Here I can simply solve for dy dx by dividing both sides by this expression here, which then gives us 8x minus 2x y squared over x squared 2y plus 4y cubed. Now, as I said before, to find any local maximum or minimum points, we need to set the first derivative equal to 0, as I did here. Now, the denominator can simply fall away, as this multiplied by 0 is just 0. So now we are left with 8x minus 2x y squared is equal to 0. We can actually make this expression even more simpler by plugging out 2x, and therefore it becomes 4 minus y squared. Using our rule, our knowledge of the null factor law here, it basically means that 2x has to equal to 0, so x is just simply equal to 0, and 4 minus y squared is equal to 0. This simply means that y squared is equal to 4, and therefore y is simply equal to plus or minus 2, due to the square root of 4 being either 2 or minus 2. Now, we are left with this answer here, y is equal to plus or minus 2. However, if you look back at the initial question, there are some restrictions placed on y. It says that y has to be between -2 and 2. However, in this case, y is equal to -2 or 2. Hence, we can simply say, due to the restrictions placed on the equation, there are no minimum or maximum points. Question 8. And in this question, we are given a cosine function. And we are asked to consider the case where k is equal to pi over 2. And by sketching this graph, we are asked to find the largest possible value of a. Now, given our knowledge of a basic cosine graph, it simply looks like this. It starts at 1 at pi over 2, it goes down to -1 at pi, and it goes back up to 1 at 2 pi. Now they're asking us to sketch the graph of cosine of x minus pi over 2, and this simply is just a cosine graph with a horizontal translation pi over 2 units to the right. I simply sketched that here for you, and as you can see, the maximum value occurs here, which is simply at pi over 2. Hence, the answer to part A is pi over 2. And this is very similar for part B. They're simply asking us to do this again, however, this time with a horizontal translation to the right of pi units. The graph will look like this, and the maximum value will once again occur at pi. And we can kind of see what the trend is now. And with this trend, we can use this to answer part C. We already know that k is simply equal to pi plus a. And they're asking us to find the value in terms of k. Hence, the answer is a is equal to k minus pi. Question 9. In this question, we are given a homogeneous differential equation, and we are asked to simply solve the equation, given that y is equal to 2 and x is equal to 1. I'm going to run you quickly through the first basic steps you need in order to solve these differential equations. Now, for the homogeneous ones, there are 3 main things that you need to know before actually solving it. You're going to be using a substitution. The substitution is simply y. You're going to replace that with vx. And you're going to need this later on to solve back for the original. You'll also need to know that v is simply y over x. You can just do this by rearranging. And in this case, you're also going to need to replace dy dx by the following. You're going to need to replace it by v plus x dv dx. Just remember that. That will allow you to genuinely solve these anytime. Like I said, you will replace dy dx with this. So I replaced that right here. V plus x dv dx is equal to, what I did here is I used the substitution y is equal to v over x. Where y was, I put in vx. As you can see, here was y squared, so it becomes v squared x squared. This stays the same, and at the bottom there's also a y, so this becomes vx squared. What I can do here is I can remove x squared from all of these, so it becomes v squared minus 2 over v, and I can also divide this by v and this by v, so I'm left with v plus x dv dx is equal to v minus 2 over v. What I can do now is I'm going to bring this v to the other side, and this simply removes both of the v's. So I'm left with x dv dx is equal to -2 over v. What I can do now is I'm going to rearrange. I'm going to put this v here, and I'm going to put this x here. So I'm now left with v dv dx is equal to -2 over x. This allows me to then bring this dx up here. Now I've separated the variables, as you can see, and I'm now left with v dv is equal to -2 over x dx. Perfect. What I want to do now is I want to simply integrate both sides. So I'm left with the integral of v dv and the integral of -2x dx. These are very simple integrals. All you need to do is just very simply integrate them. This becomes v squared over 2, and this one becomes -2 ln x plus c. You always need to remember to plus the c, and usually in the one with the ln x. What I'm going to do here now is I want to eventually be able to plug in the y equals 2 and the x equals 1 back in. And as I told you before, there's another substitution that you need to know here. V is simply equal to y over x. I did that here. I plugged them back in. This becomes therefore y squared over 2x squared. It's just simply equal to -2 ln x plus c. Now I'm going to simply plug in the values that we are given. Y is equal to 2, x is equal to 1. I did that here. 2 squared over 2 is equal to -2 ln of 1 plus c. And what you need to know here is that ln of 1 is simply equal to 0. So on this side, I'm simply left with c. And 2 squared divided by 2, which is 4 divided by 2, is 2. Therefore, c is simply equal to 2. So I'm now left with this. So y squared over 2x squared is equal to negative 2 ln x plus 2. What the question is asking me to leave it in the form of y squared is equal to f of x. So all I need to do here is bring this 2x squared to the other side. So y squared is negative 4x squared ln x plus 4x squared. And I can simply simplify this as y squared is equal to 4x squared brackets 1 minus ln x. And that is my final answer for the differential equation. Now in part B, it's asking me to find the points of zero gradient. And what we need to know here is that zero gradient is basically the first derivative equal to 0. And guess what? We are already given with the first derivative. It's simply this, y squared minus 2x squared over xy. What I can do here is I can set this equal to 0, which I did right here. This can simply go away, the denominator multiplies by 0, so I'm simply left with y squared minus 2x squared is equal to 0. Well, I will now put this to the other side, so I'm left with y squared is equal to 2x squared. I will take the root of y, so I'm left with y is equal to plus or minus root 2x. Therefore, the value of m will simply be plus or minus root 2. Question 10. In the first part of question 10, it asks us to find the root of the equation cos squared x minus 3 sine squared x. And in order to find the root of an equation, we simply have to equate it to 0. And that's just what I did here. I set the equation equal to 0, and from here on onwards, I can just solve it. I can bring this one to the other side, so it equals this now. And from here, it's a little bit of an advanced step that's not very noticeable, but what I essentially did is I brought the cos squared x to the other side, and I brought the 3 to this side. That becomes 1 over 3 divided by sine squared x over cos squared x. And using our basic knowledge of trigonometry, sine x over cos x is just tan x. This goes the same the other way, so sine squared x over cos squared x is simply tan squared x. Therefore, tan squared x is equal to 1/3, and I can simply square root the other side to get rid of the squared. Therefore, tan x is equal to 1 over root 3. Now, given our domain, the answer has to be between 0 and pi. And basically, with our knowledge of the unit circle, we will know that x is 1 over root 3 at pi over 6 and 5 pi over 6. Part B. Part B is asking us to find the first derivative of the equation. And although this may seem a bit daunting at first, it's actually not that bad. What I did here is the following. In order to find the derivative of a trigonometric equation, all I simply have to do is first of all find its initial derivative. So what I did here is I brought the 2 there. It becomes 2 cos x. However, when you find the derivative of a trigonometric one, you also have to take into account the chain rule. Not only are you finding the derivative of 2 cos x, you're also using the chain rule. The derivative of cos x is minus sine x, so I need to add that too. Therefore, it becomes minus 2 cos x sine x. And the same goes for this one. What I do here is I bring the 2 down to make it minus 6 sine x, and I also need to find the derivative of sine x itself, which in this case is cos x. Therefore, this becomes minus sine x cos x. And I can simply combine these two and make it a simple basic equation, which writes minus 8 sine x cos x. Now, in part 2 of question B, they're asking us to find the coordinates of the points in the graph of y equals f of x, where the derivative is equal to 0. So what I did here is I simply set it equal to 0. However, I first did an intermediate step to make it a little bit easier. We have a trigonometric identity in our formula booklet, which reads this. Sine 2x is equal to 2 sine x cos x. In our case, however, it reads 8 sine x cos x. It can hence be rewritten as minus 4 sine 2x. That's just a basic trigonometric rule. What I did then is I set it equal to 0 to simplify it. And the minus 4 basically cancels out, so I'm just left with sine 2x is equal to 0. When is sine 2x equal to 0? Well, it's actually equal to 0 at 0, pi over 2, and pi. Now that I have my x coordinates, I simply need to plug these coordinates back into the original equation to find my y coordinates, and that's just what I did here. F of 0, I plugged in all the zeros. The same goes for the other two. So cos squared of 0 minus 3 sine squared of 0 is just simply equal to 1. Cos squared of pi over 2 minus 3 sine squared of pi over 2 is simply equal to minus 3. And cos squared of pi minus 3 sine squared of pi is simply equal to 1. Therefore, I can write it to be 0, 1, pi over 2, negative 3, and pi 1. Those are my coordinates. Next, part C, it's asking us to sketch the graph of the absolute value of f of x. and I need to clearly show the coordinates of any points where the derivative of x is equal to 0, and any points where the graph meets the coordinate axes. Now, I'm first going to quickly sketch the original curve, because I have every single point. We calculated it before. We know it starts at 0, 1, and we know the intercepts are at pi 6, 0, and 5 pi on 6, 0, as I calculated just before here. I also know any other coordinates found in the previous part, such as 0, 1, pi on 2, negative 3, and pi 1. Next, to sketch the absolute value function, I simply need to flip anything that's on the negative side and put it on the positive side, and that's just what I did here. Instead of it being pi over 2 negative 3, it becomes pi over 2 3, and the curve will look just like this, and that is the answer to part C. And then in part D, it's asking us to solve the inequality where the absolute value of f of x is greater than 1. Now what I did here is I once again sketched the absolute value function, and I drew a line when it's equal to 1. These are the 2 points we want to be finding. However, since it's asking us when it's greater than 1 for the absolute value function, it's essentially equal to its original function being equal to negative 1. So that's just what I did here. I put the original function, cos squared x minus 3 sine squared x, and equated it equal to negative 1. What I did here now is a little trigonometric identity substitution. It's the one just here in our formula booklet. Cos squared x plus sine squared x is equal to 1. And what I did, I rearranged to make sine squared x a subject. Sine squared x hence is equal to 1 minus cos squared x. And I can plug this into here. Next I'm left with cos squared x minus 3, brackets 1 minus cos squared x is equal to negative 1. Here I simply expand, and here I add them up together. Next I'm left with cos squared x is equal to a half. I can make this cos x is equal to plus minus 1 over root 2. And if we take a look again at the question, it's asking us to find out when it's greater than 1. Well, there's only one answer for that. It's not negative a half over root 2, it's simply a half over root 2. And that's our final answer. 11. And in the first part of this question, we are given a 3-digit code, ABC, and each one of them is assigned a value of either 1, 2, 3, 4, or 5. And in part A, they're asking us to find the total number of possible codes, assuming that, first of all, each value can be repeated. Well, in this case, we just simply need to recognize that since each value can be repeated, there are 5 different combinations. So all we simply need to do is we need to multiply 5 times 5 times 5, since there's 3 possible outcomes. Therefore, the answer is 125. And then the second part is assuming that no value is repeated. Once again, very easy. All we need to consider is that, first of all, there's 5 different codes. Once that's happened, one of them is removed. There's only 4 left, so now we multiply by 4. Once again, now the 4 is removed, there's only 3 left, so now we multiply by 3. This will equal 60. In part B, they're asking us, well, they're first of all giving us a polynomial equation, x cubed plus ax squared plus bx plus c. And they're asking us to find an expression for b in terms of a, given that p of x has a factor of x squared plus 3x plus 2. Now, what we can do here is we can simply write it like this. I wrote it down, x cubed plus ax squared plus bx plus c, and I said that it's equal to, we know the factor, x squared plus 2x plus 2. However, there's also another factor, and I just call this x plus d for now. D is another variable that I called. What I did here is I rewrote this, and I expanded this part. I simply just expanded this. So I multiplied x by all of this, and then d by all of this. Now what I'm trying to do here is I'm going to group together my different terms. So the x squareds go together, I underline them. The x's go together, I squiggly underline them. And then the other variables, I circle them underneath. From this we can deduce that a is equal to 3 plus d due to the x squared. We can also recognize that d is equal to a minus 3 simply by rearranging. From this concept we can also see that due to the both x's, we can see that b is equal to 2 plus 3d. Since b is equal to 2 plus 3d, and since we have an expression for d, I can simply substitute an a minus 3 into that. Therefore b is equal to 2 plus 3 times a minus 3, which gives us 2 plus 3a minus 9, which gives us 3a minus 7. Next, they're asking us to show that the only way to assign the values is a equals 4 b equals 5 and c equals 2. We know the value has to be between 1 and 5, and the previously found expression I will now substitute in the middle. What I can do here is solve the inequality. I can add 7 to both sides, so this then becomes 8 and 12, and I can divide both by 3. Of course, 12 divided by 3 is 4, however here, this might seem a bit counterintuitive, but since it's a paper 1, this would give us a weird decimal. It would be like 2.67 or something. However, we can just round that simply to 3, just to make it more convenient. Therefore, if a is equal to 3, if I substitute that into the thing that we found before, we will find that d equals 0, and therefore c is equal also 0, which is not possible. However, if a equals 4, the other possibility, then d is equal to 1, and as a result, b is equal to 5, and c is equal to 2, just as they're asking us to show. I did all of this simply by substituting all these values into the expressions we found above. In part 3, they're asking us to express p of x as a product of linear factors. Now this once again may seem daunting, however it's not daunting at all, simply due to the fact that we already have the first part. We already know that it's x squared plus 3x plus 2, and simply because we already know what d is as well, d, the thing I wrote down before as a temporary variable, since I now know what d is, I can simply write it like this. X plus z becomes x plus 1 times the initial factor that they gave us. And I can also simply factorize this. X squared plus 3x plus 2 simply makes x plus 1, x plus 2. Therefore, my final answer is x plus 1, x plus 1, x plus 2. Now, in part 4 of the question, they're asking us to sketch p of x, clearly showing coordinates of any intercepts with the axis. Once again, it's a bit scary to draw a polynomial curve, however, we have basically calculated everything we need to know. I know my function, it's x plus 1, x plus 1, x plus 2. What I can do from here is find the x-intercept. All I need to do is set them equal to 0. Therefore, my x-intercepts become minus 1, this is twice, so it just counts as 1 technically, and minus 2. And I can draw that right here, minus 2, minus 1. I also know that my y-intercept will be 2, due to the original curve being having a y-intercept of 2. Therefore, I can simply write that here. And, you know, with all these points, I can simply draw a basic curve with arrows on each end showing how it would eventually evolve. And that is the answer to part 4. Question 12. And in this question, we are given a complex number defined by Zn, and it is given to be n squared plus n plus 1 plus I. And in part A, they're first of all asking us to find the argument of Z0. Now to do this, to find the argument of Z0, I'm simply going to plug in 0 into all the n's that are given, into all the n's. That's what I did here. It becomes 0 squared plus 0 plus 1 plus I, and this simply becomes 1 plus I. In order to find the argument of something, what we have to do is we have to take the imaginary part and we have to divide it by the real part. So in this case, it's simply 1 divided by 1, which is just 1. What we do then is we take arctan of that number, so arctan of 1. Well, when is arctan 1? It's simply when root 2 divided by 2 is divided by root 2 over 2, which occurs at pi over 4. So pi over 4 is the answer. Now in part 2, they're asking us to write down an expression for arg z of n in terms of n. Well, what we can simply do here is, as I told you before, what we do in order to find the argument, we take the imaginary part and we divide it by the real part. And after that, we also write arctan in front of it. And that's simply the answer here, is arctan of 1 over n squared plus n plus 1. Part B is a little bit more tricky, and what they're asking us to do is they're asking us to show that arctan of A plus arctan of B is equal to arctan of A plus B divided by 1 minus A over B. What we can do here is we can go to our formula booklet, and we can use this formula right here. It goes as follows. It says tan of A plus B is equal to tan A plus tan B over 1 minus tan A tan B. That's exactly what I did here. I quickly wrote down this formula right here. What I did then is I added arctan to both sides. And from this I can simply say that tan A is equal to A and tan B is equal to B. And simply simplifying this, I will eventually get arctan A plus arctan B is simply equal to arctan of A plus B over 1 minus AB. In the second part, they're asking us to show that arc of W1 is equal to arctan of 2. What we need to do here is we need to recognize that we already know what arc of W1 is. It's simply arc 0, Z0 times Z1. And knowing complex numbers, This means you can just rewrite it as arc z0 plus arc z1. We already know what the argument of z0 is. We calculated it before. It's simply 1, right here. And we also know what the argument of z1 is. We can simply use this one, and we can plug in 1s into each of them. This becomes 1 over 1 plus 1 plus 1, which is 1 over 3. So now we have arctan of 1 plus arctan of 1 over 3. Once again, we can use the formula we used before from our formula booklet, this identity here, the double angle identity, and we can substitute it into here. This gives us arctan of 1 plus 1 over 3 over 1 minus 1 over 3. This will eventually give us arctan of 12 divided by 6, which is eventually arctan of 2. Now, the final part of this question will be explored in another video in more detail, as it is an induction question which requires very much attention to detail and it can be quite tricky.